everyone. Malaysia is one of the world's top natural rubber producers, and the rubber processing industry plays a major role in our economy. However, this industry also poses serious environmental concern, especially from the discharge of untreated or poorly treated wastewater. This wastewater contains high level of organic matter, ammonia, suspended solid, and chemicals used during processing. When released into rivers, it affects water quality, harm aquatic life, and poses public health risks, especially for communities using river water for daily needs. This research aims to assess the environmental risks of rubber processing wastewater in Malaysian rivers. It will analyse their effluent composition, its impact on ecosystems, and propose ways to support better management and policy enforcement to protect our freshwater resources and ensure sustainable development.
In rubber factories, hazardous wastewater is generated during the coagulation, washing, and drying of latex. This wastewater contains several harmful substances including high biochemical oxygen demand and chemical oxygen demand, indicating large amount of organic pollution. Ammonium nitrogen, volatile, fatty acid, and hydrogen sulfide, which are toxic in both human and aquatic life. These pollutants often result from the use of industrial chemicals like formic acid and ammonia during rubber processing. The major sources of these hazardous waste are rubber factories located in Perak, Kedah, and Johor. There are three main pathways for this waste to enter the environment: direct discharge into river, suppression of the rainfall, leakage from holding ponds. These pathways leads to serious environmental impacts such as oxygen depletion in rivers, which suffocates aquatic organisms, foul odors which negatively affect nearby communities, and eutrophication and discoloration of water bodies, disrupting ecosystem and water quality. Identifying this hazard is the first step toward effective environmental risk management. Exposure to pollutants from rubber factory wastewater affect both aquatic life and humans. In aquatic environments, exposure leads to fish kill, disruption of reproduction cycle, and ultimately a loss of biodiversity. Humans can be exposed in several ways: by using contaminated river water for bathing, washing, irrigation, and fishing, through consumption of contaminated fish, and via airborne exposure to unpleasant and harmful gases like hydrogen sulfide and methane. Those at greatest risk include factory workers and residents living near these facilities, who often face long-term chronic exposure. The risk is especially high in rural areas where wastewater treatment facilities are limited. During the rainy season, the danger increases due to effluent overflow in surrounding areas. As a result, exposed individuals may experience skin irritation, gastrointestinal issues, and respiratory discomfort, highlighting the need for stronger pollution controls and community health protection.
My name is HAMZAH. My number metric is S71262. Today I want to present about those responses. Effect assessment. Number 1. Main pollutant in rubber wastewater. BOD and COD reduce oxygen. Nutrient is neutral ammonia, phosphorus. Heavy metal, lead, zinc, and manganese. Byproduct, nitrosaminous, potential carcinogen. Number 2. Effect on aquatic life. Low DO, fish kill. Zinc, more than 0.1 mg per liter, zero damage. Lead and manganese, reproductive harm. Bioaccumulation in food chain. Number 3. Human health risk. Lead, more than 0.01 mg per liter, brain damage in children. Nitrate, more than 10 mg per liter, blue baby syndrome. Nitrosaminous, cancer risk with long-term exposure. Soil, crop, algal bloom, irrigation, heavy metal in vegetable. ASSOC, FAO or WHO, safety limit. Nutrient, harmful, algal bloom, microcystin, more than 1 mg per liter, liver and skin toxicity. Thank you.
Mitigation and management measure. The first is primary treatment. Screening and sedimentation remove last solid, while equalization tanks stabilize pH and flow for consistent treatment. For the second one is secondary treatment. Activate/process ASP and sequencing batch reactor SBR degrade organic pollutant, making them ideal for rubber wastewater. For the third one, tertiary treatment. Chemical precipitation, remove heavy metals and reverse osmosis. Ensure high quality effluent discharge. For the last one is natural system. Construct wetland and biogas recovery, offer low cost sustainable solution for rural area. Regulatory and policy framework. National law. Malaysia Environmentally Quality Act 1974 set strict discharge limit BOD 20 mg and mandates licensing for industrial effluent. For the second one, enforcement. Department of Environmental conducts random inspection with fine up to 100,000 ringgit Malaysia for violations, but enforcement gaps remain. For the third one, global standard. Asian Agreement and SDG 6 align Malaysian policies with international sustainability goals. Policy gaps and recommendations: weak enforcement, boost Department of Environmental surveillance with drones and increase penalties to deter illegal discharge. For the hard cost, provide subsidy for SMEs to adopt advanced treatment like MBR and reverse osmosis. Transparency: launch a public dashboard for real-time effluent monitoring to hold industry accountable.
Assalamualaikum and a very good day. Today I will explain the risk characterization related to rubber processing wastewater or RPV in Malaysia. First, risk characterization is a crucial step in environmental risk assessment. It brings together data from hazard identification, exposure estimation, and dose response analysis to understand how dangerous a particular environmental structure, like RPV, can be to human and the ecosystem. In Malaysia, as the world's top rubber producer, many factories discharge RPV into rivers. This wastewater contains high level of POD, COD, ammonia, nitrates, suspended particles, and even heavy metals and toxic organic compounds. These pollutants lower the dissolved oxygen in rivers, which leads to fish death and biodiversity loss. The risks are not limited to aquatic life. In rural villages, people who use river water face serious health threats. For example, nitrates above 10 mg per liter can cause blue baby syndrome or methemoglobinemia in infants. Leaks above 0.01 mg per liter can lead to developmental and neurological disorders, especially in children. Even toxic gases like hydrogen sulfate can harm human health through inhalation or skin contact. Exposure happens in several ways: direct discharge, surface runoff, seepage, and indirect exposure through contaminated fish and affected factory workers. During the rainy seasons, this risk increase due to overflow and spreading. Unfortunately, poor wastewater treatment and weak enforcement make the situation worse. Therefore, urgent action is needed to strengthen regulation, improve treatment system, and protect both public health and our aquatic ecosystems.
Conclusion: an integrated approach is essential to address rubber processing wastewater risks in Malaysia. Strengthen enforcement of the Environmental Quality Act 1974 to ensure compliance. Promote advanced and cost-effective treatment technologies suitable for SMEs. Provide financial incentive and support for the adoption of cleaner technology. Increase transparency and monitoring of wastewater discharge. Engage local communities in river protection and awareness initiatives. Urgent action is needed to protect river ecosystem, public health and rural livelihoods.